Yes. In the last class, we discussed about the concentration of the ores. Next one is either roasting or calcination. This is metallurgy. General principles involved in the extraction of the metals. In that, crushing is over and concentration is over. Next, third one is roasting or calcination. Roasting or calcination. See, in concentration process, we removed the impurities as far as possible from the ore and increasing the percentage of the wanted metallic compound. Now the ore may be in any form. It may be oxide form or sulfide form or carbonate form or hydroxide form, whatever it may be. But our objective is to isolate the metal or extract the metal. The body of the metallurgy is actually the reduction process. During the reduction process, we can convert the metallic compound into the respective metal by using various reducing agents. But before going to reduce the metallic compound into the respective metal, we have to convert the metal into the respective oxide form. In oxide form, next step involves the reduction of the metal. That is oxide form of the metal to the respective metal. Therefore, during the roasting or calcination, we can convert whatever by the nature of the metal in the form of the compound. Like metallic carbonate may be there, for example, limestone or dolomite or calamine, whatever it may be, or hydroxides are there, especially bauxite and hematite. They are associated with the moisture, or hydroxides, or sulfide forms of the ore, whereas galena, chalcopyrite, cinnabar, they are sulfide forms. Now, in this operation, during roasting or calcination process, we can convert either the hydroxide form or sulfide form or carbonate form into the respective metal. First, what do you mean by roasting? What do you mean by roasting? What do you mean by roasting? As its name indicates, roasting is the word that is derived from roast. What do you mean by roast? By Greek term, that is a roast. We are heating in the presence of excess quantity of air or oxygen. Whenever any component is heated at high temperature in a current of air or oxygen, the phenomena is called roasting process or roasting operation. Now, during this process, here we are concentrated ore, not ore is heated at high temperature, here concentrated ore after ligation process, after oil froth flotation process, after magnetic suppression process, whatever it may be, the final product obtained is called as a concentrated ore. The concentrated ore is heated at high temperature in the presence of excess quantity of air or oxygen, but below the fusion point of the wanted metallic compound. If it is heated at very high temperature, then metal obtained is in the form of the molten state. Then the molten state of the metal has the ability to dissolve the impurities. Therefore, the impure components are obtained, impure metals are obtained. That is the reason why the heating can be carried at high temperature, but specification is there below the fusion point of the metal or wanted metal. This phenomena is called as a roasting. Is it clear? Now, the definition of the roasting. The process of heating the concentrated ore at high temperature in the presence of excess amount of the air or oxygen, but below the fusion point of the wanted metallic compound, is called roasting. Now, usually the sulfide ores are subjected to the roasting operation. Now, what happens during roasting? Since we are heating the concentrated ore at high temperature, then when any impurities are associated with that of the wanted metallic compound, usually the ore contains lighter components of the earth and fossil components are also there. Organic matters are there. Therefore, the objective of roasting process is any fossil components or organic matters are associated with the wanted metallic compound. They undergo combustion reaction at high temperature in the presence of air or oxygen. Therefore, organic matter destroys. When any organic matter is subjected to roasting process, finally it gives a carbon dioxide and water. Water is in the form of the water vapor. Therefore, carbon dioxide expels and water that convert into moisture or vapors of the water, both that volatilizes at high temperature, vaporizes at high temperature. And any sulfide components are there. Since the ore is sulfide form, this method is employed in the extraction of lead from galena, copper from chalcopyrite, mercury from cinnabar. Usually the roasting operation is carried. Now, during this process, moisture expels, carbon dioxide volatilizes, organic matter destroys. And suppose PBS is there, it undergoes oxidation reaction during roasting, then it gives rise to PbO plus sulfur dioxide. If cinnabar, mercuric sulfide, that undergoes oxidation reaction at high temperature, then it gives rise to mercuric oxide and sulfur dioxide. Equation is not balanced. Now, when chalcopyrite CuFe is 2, that undergoes oxidation reaction during roasting process, then it gives rise to Cu2s and FeS. Then FeS is converted into ferrous sulfide is converted to ferrous oxide. Ferrous oxide and sulfur dioxide. Sulfur dioxide. Therefore, ore becomes more porous in nature. Now, what are the changes that occurs during roasting process? During roasting process, first one, organic matter destroys. Organic matter destroys because organic matter undergoes combustion reaction, then it gives rise to carbon dioxide and water. Both that evaporates. both that evaporates. And sulfides are converted into oxides with the liberation of sulfur dioxide. With the liberation of sulfur dioxide. Sulfur dioxide that escapes. If arsenic and antimony are present, then they undergoes oxidation reaction. Then it gives rise to arsenic trioxide and antimony trioxide. Arsenic trioxide and antimony trioxide. Now these volatilizes at high temperature. These volatilizes at a high temperature. See, what about the changes that occurs during this roasting process? First one, organic matter destroys. Because organic matter usually undergoes combustion reaction with air or oxygen, it gives rise to carbon dioxide and moisture or vapors of the water. Sulfides are converted into the respective oxides with the liberation of the sulfur dioxide. The oxides are further reduced with different reducing agents. Then we can obtain the metal in the form of the molten state or fused state. If any arsenic or antimony are present, even phosphorus is also present, then it is converted to arsenic trioxide or antimony trioxide and they volatilizes. And ore becomes more porous in nature. Ore becomes more porous in nature. And can be used for next operation, that is called smelting or reduction operation. Now very important, what you mean by roasting and which type of the ores are subjected to the roasting. What are the changes that occurs, physical and chemical changes that occurs during roasting process? The process of heating the concentrated ore at high temperature in the presence of excess quantity of air or oxygen, but below the fusion point of the metal or below the fusion melting point of the metal is called roasting. Now below the fusion point, because when it is heated above the fusion point, then metal melts and it has ability to dissolve the impurities. Therefore the metal obtained is in impure form. That is the reason why it is carried at low temperature in the sense compared to that of the melting point of the wanted metal. Usually sulfide ores are subjected to the roasting process. Sulfide ores means in the extraction of lead from galena, in the extraction of mercury from cinnabar, in the extraction of copper from chalcopyrite, we are using roasting process. Now what are the important changes that occurs during roasting process? During roasting process, the important changes are, since the ore is associated with organic matters in the sense fossil components of the earth. Now when there comes in contact with air or oxygen at high temperature, the fossil components invariably contains carbon and hydrogen. Therefore carbon part is oxidized to carbon dioxide and hydrogen part is subjected to water. Therefore carbon dioxide and vapors of the water are formed during roasting process and can be expelled. And sulfide ores are converted to the respective oxides, that is obviously because they are heating in the presence of air or oxygen, and hence it is converted into sulfur dioxide. Metallic oxides are obtained with the liberation of sulfur dioxide. Now if any arsenic or antimony or even phosphorus is also present, They are converted to the respective oxides like arsenic trioxide or antimony trioxide, and ore becomes more porous in nature and can be used for next operation, that is called reduction operation. Is it clear? This is about roasting process. This is about roasting process. Next one is, what do you mean by calcination process? What do you mean by calcination process? The next one is calcination process. Calcination process. Now the roasting can be carried by using reverberatory furnaces. Now during the calcination, what do you mean by calcination? This is also the process that we can carry it after concentration process. Now after concentration process means the ore obtained is called as a concentrated ore. Now what is the main difference between roasting and calcination is, during roasting the concentrated ore is heated at high temperature, but during calcination process the concentrated ore is heated in the absence of air or with limited supply of air. Either in the absence of air or with the limited supply of the air, we can carry the calcination process. Now, what is calcination? The process of heating the concentrated ore at high temperature in the absence of air or oxygen, or with limited supply of air or oxygen below the fusion point of the wanted metal or metallic compound, is called calcination process. Now, very important, you have to underline the word in the absence of air or oxygen or with limited supply of air or oxygen. This is the difference between roasting and calcination process. Now, which type of the ores are subjected to the calcination process? Especially carbonate ores and hydrated ores or hydroxide ores are subjected to calcination process. The important difference is in the absence of air or oxygen. In the absence of air, in the absence of air, in the absence of air, or limited supply of air. In the absence of air or limited supply of air. Limited supply of air. But during roasting, excess amount of air, that is the difference between roasting or calcining. Which type of the ores are subjected to this calcination operation? Usually carbonate ores, carbonate ores, carbonate ores and hydrated ores. Carbonate ores and hydrated ores are subjected to the calcination process. Carbonate ores in the sense, in the extraction of calcium from limestone and in the extraction of zinc from calamine, in the extraction of lead from lead carbonate, even in the extraction of magnesium from dolomite we are using. Now the hydrated ores means bauxite, Al2O3, 2H2O, or hematite, 2Fe2O3, 3H2. This is bauxite and this is hematite. Now carbonate ores or hydrated ores or hydroxide ores are subjected to the calcination operation. Now, what are the changes that occurs during calcination process? Since we are heating the carbonate ores or hydrated ores at high temperature, and also it is heated in the limited supply of the air or oxygen, why it is necessary to heat with limited supply of the air or oxygen? Again, same concept. If it associates the fossil components, which contains organic matter, organic matter that undergoes either they contains carbon and hydrogen. Therefore, carbon part is oxidized to carbon dioxide, and hydrogen part is oxidized to moisture. That is H2O at high temperature, it is converted into moisture. Therefore, carbon dioxide and moisture both expels CO2 and H2O, that is in the form of vapor. They expels at high temperature. Therefore, organic matters can be removed. Second one, since it is associated with the carbonate, calcium carbonate, on heating at high temperature, then it gives rise to calcium oxide and carbon dioxide, and calamine, suppose zinc carbonate, on heating at high temperature, then it gives rise to zinc oxide and carbon dioxide. And if PbCO3, lead carbonate on heating, it gives rise to PbO plus carbon dioxide, that is litharge. When it is magnesium carbonate, that is in the form of the dolomite, when it is heated at high temperature, then it gives rise to magnesium oxide and carbon dioxide. Similarly, when oxide ores are subjected to moisture, since hydrated oxides, that is Al2O3 2H2O, that is bauxite, on heating at high temperature, in the absence of air oxygen, then it gives rise to Al2O3 plus 2H2O. Whenever this hematite, it is 2Fe2O3, 3H2O. This is hematite. On heating at high temperature, then it gives rise to Fe2O3 plus 3H2O. Fe2O3 plus 3H2O. Now, moisture that expels at high temperature, here we have only the aluminum trioxide and ferric oxide, these are formed. Now, what happens? What about the conclusions that we can draw from this calcination operation? During calcination operation, organic matter destroys, carbonates are converted into respective metallic oxides with the liberation of carbon dioxide. Carbon dioxide is a volatile and hence it expels from the metallic compound. If the ores are hydrated forms, for example bauxite or hematite, then they loses moisture or water of hydration. Then all the cases, say calcium in the form of calcium oxide, magnesium in the form of the magnesium oxide, zinc in the form of the zinc oxide, and lead in the form of the lead oxide, and aluminum in the form of the aluminum trioxide, and iron in the form of the ferric oxide, these are formed. Just observe, metals are obtained in the form of the respective oxides. And impurities, they evolves, or impurities expels at high temperature. Now, whenever the carbon dioxide is liberated, then ore becomes more porous in nature and can be subjected to the next operation very easily. Now this is about the roasting operation. Now conclusion, either during roasting operation or during calcination operation, the final form of the metal is in oxide form. Therefore, the oxide of the metal is subjected to the last process, next process, that is reduction process. Next one is the reduction process. This is actually the body of the metallurgy. This is third one. First one is crushing, second one is concentration, third one is roasting or calcination, fourth one is reduction of the metals. Reduction process. Means here metallic compounds can be converted to metals. Metallic compounds can be converted into metals. Metallic compounds can be converted to metals. Here, depending upon the nature of the metal, they are classified into different one. First one is electrometallurgy. Usually the metals which belongs to the first A group and second A group, aluminum. This class of the metals can be extracted by means of electrometallurgy. For example, in the extraction of sodium, in the extraction of lithium, in the extraction of potassium, in the extraction of beryllium, in the extraction of magnesium, in the extraction of calcium, in the extraction of barium, in the extraction of aluminium. In our entrance exam, they may give us the options. Which one of the following metal can be extracted by electrometallurgy? Highly electropositive metals, means group 1 metals and group 2 metals. Group 1 metals means except hydrogen, like that of lithium, sodium, potassium, rubidium, cesium. Group 2 metals like beryllium, magnesium, calcium, strontium and barium. In addition to this, aluminium in the P block. These metals are extracted by electrometallurgy. Now during electrometallurgy, what you are doing? Here for example, sodium in the form of the sodium chloride. Here which is the reducing agent? Electricity is the reducing agent. Here which is the reducing agent? Electricity is the reducing agent. Here we are using electricity is the reducing agent. Just observe, whenever sodium in the form of the sodium chloride is subjected to electrolysis. Sodium in the form of the sodium chloride is subjected to the electrolysis. What do you mean by the electrolysis? Electro means electricity. Polysis means splitting up of the covalent bond. The splitting up of the ionic bond, splitting up of the ionic bond in the presence of electricity is called electrolysis reaction. During electrolysis reaction, when current is made to pass into the fused solution or molten solution or aqueous solution of the electrolyte, because solid metallic compound cannot be subjected to electrolysis reaction, because in solid state the electrostatic force of attraction between the positively charged and negatively charged ions will be high, and hence they cannot subject it to electrolysis reaction. Now after passing electrolysis reaction, it is converted into Na plus and Cl minus. Na plus and Cl minus. Now Na plus is called as a cation, Na plus is called as a cation, no confusion, and Cl minus is called as a anion. Na plus is called cation and Cl minus is called anion. Now what about the cation? Cations migrates towards cathode. Cations migrates towards cathode. Migrates towards cathode. Migrate towards cathode. Anions migrates towards anode. Anion always migrates towards anode. Now try to understand. Now Na plus is obtained. Now nature of the cell reaction across anode is oxidation reaction. Nature of the cell reaction. Nature of the cell reaction. At anode, oxidation reaction. At anode, oxidation reaction. At anode, oxidation reaction. At cathode, reduction reaction. At anode, oxidation reaction, and at cathode, reduction reaction. Now Na plus ions are cations. They migrate towards cathode in the applied field. Across cathode, reduction reaction occurs. Reduction means addition of an electron. Then sodium ion captures one electron. Because that positive charges, that signifies how much electron that we can add. If the charge beared by means of the positive ion is 1 electron is required. Charge beared by means of the positive charge is 2 electrons are required. Charge beared by means of the positive ion is 3, then 3 ions are required. Now this is called as a reduction process. This is cathodic reaction. This is called cathodic reaction. Therefore, across cathode, sodium is deposited. Sodium is deposited. Now, Cl minus ion is called anion. Anions migrates towards anode. Nature of the cell reaction across anode is called oxidation reaction. Then it gives rise to Cl. But chlorine occurs in diatomic state. Chlorine occurs in diatomic state. Therefore, across anode, chlorine gas is liberated. Across anode, chlorine gas is liberated. Now this is about the cell reactions. Whereas sodium is deposited across the cathode and chlorine is discharged at anode. Chlorine is discharged at anode. But during this process, we have to add calculated quantity of the calcium chloride. Calculated quantity of the calcium chloride. This calcium chloride that lowers the melting point of the electrolyte, and it increases the electrical conductivity increases the electrical conductivity. It lowers the melting point of the electrolyte and it increases the electric conductivity of the sodium chloride. Electrical conductivity of the sodium chloride. Electrical conductivity of the sodium chloride. Electrical conductivity of the sodium chloride. And also it does not involve in the corrosion of the metals. Therefore, we are adding calcium chloride. What is the role of the calcium chloride? Usually in competitive exam they will ask the role of the calcium chloride in the extraction of the sodium from sodium chloride or seawater or brine solution, whatever it may be. The role of the calcium chloride is to decrease the melting point of the metal, decrease the melting point of the sodium chloride, and hence increases the electrical conductivity. Why it is need to reduce the melting point? Because in the absence of the calcium chloride, sodium is deposited. In the absence of the calcium chloride, The reduction process will take place at high temperature. At this high temperature, sodium is in the form of the sodium vapor. The sodium vapor, by using sodium vapor, we can't obtain the sodium because fog or mist is obtained with respect to the sodium. Is it clear? That is the role of this calcium chloride in the extraction of the sodium from sodium chloride. This is about electrometallurgy. This is about the electrometallurgy. This is about the electrometallurgy. Next, aluminothermal process. Aluminothermal process. Here, aluminum is a reducing agent. Aluminum powder. Aluminum powder is reducing agent. Aluminum powder is reducing agent. Thermite means it is an exothermic process. Thermite means heat energy is liberated. Heat energy is liberated. That is sufficient to maintain the metal in the form of the molten state. This is sufficient to maintain the metal in the form of the molten state. Sufficient to maintain the metal in the form of molten state. Metal in the form of molten state. Metal in the form of molten state. Now what is a molten state? That is a fused state. Now aluminum powder is the reducing agent. In electrometallurgy, electricity is the reducing agent. Here thermite means the process is exothermic reaction and hence heat energy is always liberated. Therefore aluminothermite process is always exothermic in nature. Therefore delta H is always negative. Delta H is negative for this process. Delta H is equal to negative for this process. Negative for the process. Delta H is negative for the process. Is it clear? Now which type of the metals are subjected to this aluminothermite process? Now the metals which are obtained usually less electropositive metals in the form of the oxide state. Less electropositive metals in the form of the oxide state. This means in the extraction of chromium from chromite, in the extraction of manganese from pyrolusite. Now which type of the metals we are using? Less electropositive metals in oxide form. Less electropositive metals. Less electropositive metals. Less electropositive metals in oxide state. In oxide state. Less electropositive metals in oxide state. Example, in the extraction of chromium and in the extraction of manganese. Chromium in the form of chromite, that is chromite, Cr2O3. In the extraction of manganese from pyrolusite. This is chromite and this is pyrolusite. In these extractions, we are using in some extent to that of this iron, but in iron we are using the pyrometallurgical operation. Now aluminothermite process. What is aluminothermite process? In aluminothermite process, aluminum powder is the reducing agent. Aluminum powder is the reducing agent. As its name indicates, thermite heat energy is liberated. Therefore, this heat energy is sufficient to maintain the metal in the form of the molten state. Delta H of the process is always negative for aluminothermal process. For which type of the metals we are using aluminothermal process? Very important, less electropositive metals which occurs in the oxide form, that is chromium extraction in the form of the that is ore is chromite. Manganese extraction from pyrrolite we are using. Now very important in this process, whereas chromic oxide Cr2O3 plus Al on heating, there is a pyrrolite plus aluminum on heating, then it gives rise to Al2O3 plus chromium. Equation is not balanced. Al2O3 plus chromium, manganese, Al2O3 plus manganese plus delta means energy, heat energy is liberated, plus energy. Now here the ignition temperature is required. Take this mixture of the chromite ore and aluminum powder, or take the pyrrolite and aluminum powder, and the mixture is heated in the presence of barium peroxide and magnesium. Barium peroxide and magnesium, that is considered as a ignition mixture in the extraction of aluminum from bauxite. Whenever barium peroxide and magnesium ribbon or magnesium pieces are used, then it ignites the reaction mixture. Once the reaction is ignited, then the reaction is exothermic reaction, and hence the sufficient amount of the energy that can be obtained by this process. Okay, now in entrance exam they may ask the question, the role of the magnesium or role of the barium peroxide during the aluminothermal process dash. It acts as a ignition mixture. Very important for exam point of view to remember which type of the metals are extracted by aluminothermal process and which type of the metals are extracted by means of electrometallurgy. Highly electropositive metals like group number 1 or 1A or group number 2 or 2A and aluminum, these metals are extracted by means of electrometallurgy. And very important, in aluminothermal process, these two metals are employed. Chromium and manganese extraction, very important, from the oxide ore, This is about the key equation. There is a chromite ore, when it is heated with aluminum powder, then it gives rise to aluminum trioxide and chromium. Pyrrolite, when it is heated with aluminum powder, then it gives rise to aluminum trioxide plus manganese. In both the cases, the reaction is exothermic in nature. Since the reaction is exothermic and hence the energy is liberated sufficient to maintain the metal in the form of the molten state. Is it clear? Fine. Next one is auto reduction process. Auto oxidation and reduction process. Auto oxidation and reduction process. Now auto means a self. Auto here refers to self. Auto means self. Here no outer side reducing agents are employed. Metallic compounds itself as a reducing agent. Now, which type of the metals are subjected to the auto-oxidation reduction process? Especially the metals which are less electropositive in nature occurs in sulfide forms. Metals which are less electropositive in nature in oxide forms, aluminothermate process. Metals which are less electropositive in nature and occurs in sulfide forms, auto-reduction process. Auto-reduction process, especially in the extraction of lead from galena, in the extraction of mercury from cinnabar, in the extraction of copper from chalcopyrite. In the extraction of copper from chalcopyrite. Now, galena is subjected to auto-oxidation reduction process. Cinnabar is subjected to auto-oxidation reduction process. Chalcopyrite is also subjected to auto-oxidation reduction process. Here, in the crushed and powdered ore, after the roasting operation, now it is heated in a current of air or oxygen. Heated in a current of air or oxygen. Now, suppose PbS plus O2, but controlled oxidation reaction. This is very important. Controlled oxidation reaction. Controlled oxidation reaction. How much quantity of the air that should be passed, or how much quantity of the oxygen that should be passed, that is very important. Now, till 2/3 of the metallic sulfide is connected to the respective oxide. Till 2/3, only 2/3 of the metallic compound or metallic oxide is oxidized. Metallic sulfide is oxidized to the respective oxide. Oxidized to the respective oxide. Now, at this time, the oxygen supply is cut off or air supply is cut off. Air supply is cut off. Then, the unconverted iron sulfide and iron oxide that both react, then it gives rise to metal and sulfur dioxide. Here 1/3 of the lead sulfide is remaining and 2/3 of the lead oxide is remaining. Therefore, 1/3 of the lead sulfide that reacts with the 2/3 of the lead oxide or lead monoxide, then it gives rise to the metal, that is a metal lead, and sulfur dioxide is evolved, that expels since it is a volatile compound. Therefore, lead is extracted from galena by using auto-oxidation reduction process. Now, any metal which occurs in the form of the respective sulfides, that is lead in the form of the lead sulfide, mercury in the form of the cinnabar, copper in the form of the chalcopyrite. For example, your syllabus includes the copper in the form of the chalcopyrite. Copper in the form of the chalcopyrite. Copper in the form of chalcopyrite. Now, in the extraction of copper, CuFeS2. Now, here you have to pass the air or oxygen at high temperature, then it is converted to Cu2S plus FeS plus sulfur dioxide and FeO and sulfur dioxide during roasting, and Cu2S is subjected to oxidation reaction, limited supply of air or oxygen, controlled oxidation, Cu2O plus S4. Cu2O plus S4. Now, 2/3 of the Cu2S, 2/3 of the Cu2S undergoes oxidation reaction, and 1/3 of the copper sulfide, it is not involved in as such, not involved in oxidation reaction, Now, here Cu2S 1/3 is there and Cu2O is 2/3 is there. Then finally, on heating, now it gives rise to copper and sulfur dioxide. Now, this is a reducing agent. This is reducing agent and this is oxidizing agent. This is oxidizing agent. Now, within the reaction mixture, we have oxidizing agent and a reducing agent. Within the reaction mixture, we have oxidizing agent and reducing agent, and hence the term is called mutual oxidation reduction reaction, self-oxidation reduction reaction, or auto-oxidation reaction. Auto-oxidation reaction, self-oxidation reduction reaction, mutual oxidation reduction reaction. We are especially extracting copper, lead and mercury. You have to remember electrometallurgy is employed in the extraction of alkali metals and alkaline earth metals and aluminum. Aluminum thermite process is used in the extraction of chromium and manganese. Auto-oxidation reduction process is used in the extraction of copper, in the extraction of lead and mercury. Okay? Now this is very important. And here sulfur dioxide is liberated and molten metal is obtained. Molten metal is obtained. Last one is called as a pyrometallurgy. 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 Here pyro is called temperature. Pyro is called high temperature. Here pyro means at high temperature. Now the extraction of the metal from the respective metallic compound at high temperature by using suitable reducing agent. Here suitable reducing agent here corresponds to carbon reduction process. In pyrometallurgical operation, we are using carbon as a reducing agent, coke as a reducing agent, or carbon as a reducing agent. Is it clear? In the presence of suitable chemical substances, the added chemical substances are called flux or fluxes. What is the role of the flux during the extraction of the metals, especially in pyrometallurgical operation? Because in concentration process, we can remove only certain quantity of the impurities. 100% of the impurities cannot be removed by means of any one of the methods in concentration process. Therefore, small quantity of the impurity that left behind during the concentration process that can be removed by using pyrometallurgical operation using suitable chemical compounds. They are called as a fluxes. Now, very important, during the pyrometallurgical operation, metallic compound which is in the form of the metallic oxide is used, and carbon is a good reducing agent in pyrometallurgical operation. In addition to the carbon or coke, we are using suitable fluxes depending upon the nature of the impurity. If the impurity is basic in nature, acidic flux should be used. If the impurity is acidic in nature, basic fluxes that should be used. A flux is a chemical substance which is added during the smelting operation in order to remove the impurity in the form of the slag. Slags are not waste materials. Usually they are the silicates or the phosphate metallic compounds. These are not waste materials. Usually silicate slags are used in the construction of the bricks. Bricks means they are fire resistant bricks. They have ability to withstand high temperature, especially in boilers. In boilers, we are using in the construction operation this type of the silicate bricks because they have ability to retain the high temperature, withstand the high temperature. Okay. Now in the pyrometallurgy, especially in the extraction of iron from hematite. In the extraction of the iron from hematite, we are using this pyrometallurgical operation. Here, flux. It is a chemical substance. Flux is a chemical substance. Helps in the removal of impurity. Impurity in the refers to gangue materials. There are two types of the impurities: acidic impurity, acidic gangue, or basic gangue. Acidic or basic gangue. Nature of the acidic gangue is, suppose silicon dioxide or sand. Nature of the basic is limestone. Limestone is basic in nature. Basic in nature. Therefore, in order to remove these impurities, suppose in order to remove the SiO2 impurity, we are adding basic flux. Here the fluxes are two types. Fluxes are two types. Again same, acidic flux and basic flux. Acidic flux and basic flux. Now what are fluxes? Fluxes are the chemical substances used to remove the gangue particles or impurities during smelting operation. Depending upon the nature of the impurity, two types of the fluxes are used. They are acidic flux and basic flux. Nature of the acidic flux is sand or silicon dioxide. Nature of the acid gangues or impurities are two types: acidic gangue or basic gangue. Acidic gangue, good example is sand. Basic gangue, good example is limestone. Based upon this, two types of the fluxes are used: acidic flux or basic flux. Acidic flux is used if the gangue is basic in nature. Basic flux is used if the gangue is acidic in nature, because they undergoes neutralization reaction. Whereas gangue plus flux, that gives rise to slag. Gangue plus flux gives rise to slag. For example, if gangue is acidic in nature, for example in the extraction of iron from hematite, then basic flux is used, that is limestone, CaCO3. On heating it gives rise to calcium oxide, then at high temperature it gives rise to calcium silicate. This calcium silicate is the slag. Therefore, in the extraction of iron from hematite, in order to remove the sand impurity, limestone flux is used. Limestone on heating gives rise to calcium oxide. This calcium oxide fuses with that of the sand, it gives rise to calcium silicate. Now what are slags? Slags are the neutralized products obtained during smelting operation by the reaction between gangue and flux. Slags are the neutralized product obtained during the smelting operation by the reaction between gangue or impurity with flux. Now, slags are the not waste materials. They are useful materials. Usually silicate slags or phosphate slags are obtained. They are used in the construction of the fire resisting bricks or thermal resisting bricks. Is it clear? Therefore, these slags are usually useful products during the metallurgical operation. Now, suppose if in the extraction of copper from chalcopyrite, iron oxide is impurity. Iron oxide is impurity. Ferrous oxide is basic in nature. Therefore, to remove the ferrous oxide, sand is the flux is used. This is acidic in nature. Therefore, on heating, it gives rise to iron silicate slag. Therefore, iron silicate is the slag that is obtained during the extraction of the copper from chalcopyrite, and calcium silicate is the slag that is obtained by the extraction of iron from hematite. Now, this is about the fluxes and slags. Now, reducing agent used is carbon reducing agent. Okay. Now, this is about the 4 important reduction process: electrometallurgy, aluminothermate process, auto reduction process, and pyrometallurgy. Is it clear? Now, next we can discuss the one by one. That is a refining operation. Thank you.